Hello everybody, thanks for joining our heat session today. For those of you who don't know me yet, my name is David and I'm working here as a responsible key account manager and also as a responsible area sales manager for East Europe region here at PROBAT. So nice to meet you. In today's session we are going to talk about the roasting process in general, but also how we as PROBAT can provide you, our customers and friends, with the right knowledge and the right tools to optimize your roasting process, for example, regarding energy efficiency. You know that PROBAT is not only a machine supplier. We are more than that. Coffee is part of our business DNA. Therefore, we understand our position in the market as your go-to partner. That means that in case that you have any kind of questions regarding coffee or the process behind, you can come to PROBAT and we'll provide you with the right solution and an answer on your questions. Therefore, we have a special trainer team here at PROBAT. And one of these members is my colleague Ivana. So thank you very much, Ivana, for joining us today. So Ivana will lead us through this heat session today. She will give us a short overview about the roasting process and also provide some special insights. So Ivana, I think it would be a good starting point to present a general overview. But before you start, please let me emphasize that if you have any kind of questions, please use our chat so that we can handle these questions during our session. Thank you very much. Ivana, the stage is yours.
Yes, so I will start with a refresher on the roast development of one batch of coffee. And I prepared for this purpose some samples in front of me. So I will start with normally when we start a roasting process, we charge the green beans into the roaster. And the first phase of the roasting process is just a simple drying of the beans. So this means there's no color change. We start with an initial moisture of 10 to 12%, and then we dry down the bean matter until we reach 5 to 60%. At this point, then we see a small color change into yellowish color. And this is a signal for us that we know from this point onwards, the chemical reactions inside of the coffee start, which form then in the end the typical roast flavors, the typical roast aromas, and the main reaction behind this is the Maillard reaction. And this reaction, like I said, forms these typical roast aromas, but also these nice brown pigments. So from this point onwards, we develop the brown color, we get darker and darker. So we first pass the cinnamon color, then we reach a light brown color, and at this point we can also hear something. Yeah, so at some point we suddenly hear a cracking noise inside the roaster, and this is caused by the beans, and it's due to the volume development of the beans. So we have a high pressure build up inside the bean, which causes the bean to develop in the volume. So we increase the volume, and at some point we reach a maximum volume, so the bean matter can't resist anymore this pressure, and we hear this cracking noise.
Do you have any idea about how much pressure is inside of the bean? So just a rough number?
Yeah, so usually you can say it's between, we have a build-up pressure build-up of 5 to 20 bar inside the bean, depending on how you roast. So how fast you roast, how dark you roast. The darker you roast, the more pressure you will build up, also the faster you roast. Yeah. So up to first crack, like I said, we have the maximum volume build up. Between first and second crack, the volume buildup is quite stable, and then from second crack onwards, volume develops again. And the second crack is a cracking noise we hear as soon as the combustion reactions start, which is the pyrolysis reaction. And at this point, we develop a lot of CO2, carbon dioxide, and also, of course, carbon monoxide, other volatile compounds. but mainly carbon dioxide, which then causes again a volume increase. So we have on the one point, we have the volume increase from green to brown, pressure build up. This pressure build up at this stage of second crack causes also the oils to appear on the outside of the bean. So from second crack onwards, you can't avoid to have oils on the outside. And we also have a weight loss. So we start with 10 to 12% moisture. At yellow, we are at around 5 to 6%. And then from first crack onwards, we will be somewhere between 2 and 1% residual moisture. Yeah, so in general, we can say the first phase of the roasting up to the first crack is typically endothermic phase. Endothermic means in this case we need to insert energy, otherwise nothing happens with the beans. They will not dry out on their own, and they will also not create these typical roast flavors. And then from first crack onwards, the chemical reactions shift into exothermic reactions, which then release some energy as well.
Yeah. I think this exothermic reaction is also a very, let's say, important phase of the roasting process, also for our customers, because in case of any power failure, for example, we release emergency water into the drum or roasting chamber to prevent that the coffee getting hotter and hotter, right?
Yes, and
so that is
it's avoiding the coffee to start burning or glowing. At least, so this is the purpose then of the emergency water in this case. And also the quenching system inside the roaster is designed to stop these exothermic reactions.
Okay. Yeah. Thank you very much, Ivana, for this short overview, for this very interesting overview. I think it was a good, interesting knowledge refresher for all of us, but I'm also sure that the one or the other also learned new aspects about the roasting process. To demonstrate these, let's say, theoretical aspects in a more practical way, we have prepared a short video clip in advance. In this video clip, we roasted a coffee batch on our drum roaster Neptune 1000. And we are now going to show you this little nice video clip and see you after the video clip again. Enjoy. So, now we are standing in front of our newest drum roaster model, the Neptune 1000. And as I saw, we are almost ready to roast. So I see that the green coffee is already filled in. Ivana, maybe you can give us some insights about the green coffee that we are going to roast?
Yeah, this is our house blend. So it's a 100% Arabica containing Colombian coffee, Peruvian coffee, Papua New Guinea and Brazil.
Nice.
And we will roast it approximately in 15 minutes to a medium color.
Nice, okay, let's go.
Yes. The roaster is currently in standby mode, so we are keeping a certain supplier temperature, and as soon as I release the burner, we will start to heat up to 220 degrees charging temperature, and the coffee will be loaded into the roaster. Okay, so now I will release the burner from standby mode, and as soon as we have reached 220 degrees charging temperature, the coffee will be dropped into the roaster.
Okay, nice.
So we are right now at 183.5. The burner is heating up. So a few seconds more, and now it's dropping. Now the coffee is inside the roaster.
Yeah.
We just need to wait now another 4 to 5 minutes until we see a color change. So for now it's just a drying process. So now we are approaching the color change.
Ah, okay.
We are at 148 degrees.
Okay.
And you can see that the beans are turning into yellow color.
Yeah. So the Maillard reaction are starting now.
The Maillard reaction has started. Okay. So now we are, the next step is the first crack.
Okay.
So now we're waiting for the first crack.
Yeah.
I will set a marker as soon as I hear it.
Yeah, there are some noises. Yeah, some popping up.
Yeah, it has already started.
Ah, yeah. Yeah, now we can hear it, yeah. Okay, you set the marker, right?
Yes, and
Perfect.
from now on we have aroma development phase.
Perfect. Okay.
Now we're waiting for the roast end temperature to be reached. And then the quenching will start. We have 9 liters of water which will be quenched on 200 kg of roasted coffee. And as soon as this is finished, we release the coffee onto the cooler.
Perfect. Yeah.
So now we are approaching roast end temperature. I will end the roast manually as soon as I have the right color.
What color is it about?
It's a color at 98.
Ah, okay. So quite dark.
Medium color, yes.
Medium.
So it's right in front of the second crack.
Yeah.
So 205.9 degrees Celsius.
So the cooling sieve is starting.
The quenching has started now.
Yeah.
And now it has finished. So now we will release the coffee onto the cooling top. It's a nice color, I would say.
Looked like that we reached the desired color. So far it was great roast. Thank you very much for this roast. Thank you for the insights. Yeah.
So I will take a sample. And this is our coffee. Maybe we can check the color to see if we've met.
Check, yeah. So now we are grinding the coffee, right?
Correct. Looks a bit darker. No, it's a 96.
Oh.
We're very close. A little bit darker, so we wanted to have a 98. Now it's a 96, 2 points darker.
Perfect.
But I think that's fine.
That's fine. The
We can accept it. Yes, we can also measure the moisture. With near infrared, we do 1.7.
Good.
Nice.
Okay.
That's
Thanks
it.
again.
Thank you. Yes, so welcome back. Now we've seen how coffee is roasted in real life. Usually we can say to turn a green bean into a brown one, we need around 300 to 500 kilojoules per kilogram of coffee. And this is of course then depending on which sort of coffee you use. So usually for Arabica coffee we need a bit less energy. For a Robusta coffee we need more energy. And also in the Arabica region, when we look on a low dense coffee, it needs less energy than a high dense coffee. And then on the other hand, it's depending on how fast you roast and how dark you roast, how much energy you need for the process. Yeah, so in general, there are some options and some possibilities to reduce the energy we need for this roasting process. One option, for example, in general, it's important to have a stable process, to have a low amount of downtimes, no standbys. So a continuous process is always good energy-wise. You have, for our industrial roasting systems, we have the option to recirculate roast gases. So the exhaust gas is brought back to the burner, back again. And so we already have an energy-loaded air, which is then transferred back to the burner, and we need to heat it up a little bit less.
Which makes absolutely sense. Yeah.
This is already an option to reduce energy demand up to, I would say, 30–40%, depending on how you roast. Yeah. Then another option would be, for example, a green coffee preheating system. This is a system we can apply between a charging hopper and a roaster body. So it's a separate bin where you can heat up the coffee up to 90–100 degrees Celsius, so just to the boiling point of water. Only with the exhaust gas you would have anyways out of your system. So we use the clean air from the catalyzer, bring it back into the green coffee preheater and heat the coffee up. And then when it enters the roaster, it's already at a certain temperature, so you don't have to heat it up to this temperature. So with this, you can save up to 20% of energy. And additionally, you have also a capacity increase because your roasting times in general will be shorter. Yeah. Yeah. Another option, low temperature catalyzers. Yeah, this is also a good possibility to reduce the energy demand, because standard catalyzers used in our systems are usually working or operating at a temperature of around 600 degrees. Yeah, so this is the only energy which has to be produced for the exhaust air treatment. And with low temperature catalyzers, we can reduce this energy demand to 300–400 degrees Celsius, so much lower energy demand, and we can save a lot of gas in the end. Yeah. Sure. Yeah. So these are some options to gain back some energy in the system.
Yeah. So I think for all of our viewers, it is clear that you need a certain kind of energy level to start the roasting process. You need to start the Maillard reaction. That's for sure. But can we as PROBAT provide our customers some special tools so that they can optimize their own roasting recipe in regard to energy? Do we have some tools that we can provide our customers?
Yeah, so we just currently implemented a tool which is called Curve Design Mode. So in the Curve Design Mode, this is a tool which is applied to the basic recipe or not the basic recipe, but the recipes of our Pilot 2020 roaster control. And it is part of the roasting recipe. So you can see it, I think, now on the screen. In general, first of all, you need to roast a batch of coffee to have a roasting curve to this recipe you've adjusted. And then in the curve design mode, you have the option to drag and drop some points of this curve and to optimize your curve, not only in regard of energy demand, but also for example, to enhance some flavors, to change, make some fine adjustments in the recipe. So here in this case, up to now we have 3 drag points. We can set up to 20 drag points. I just say now I take 9 points, and you see now that the curve is divided into 9 points, and these points are able now to be dragged or dropped. You see I can increase them or decrease them. I can also move them to the left and to the right, and with this I can shape a certain curve, a certain roast profile to optimize, to fine-tune my roast.
Okay, so talking about this topic of energy levels and to optimize roasting curves, that leads me to another important topic, which we get often message from our customers in this regard. So this topic of acrylamide. And just out of the curiosity, is this topic of acrylamide linked anyhow to this topic of energy levels? Is there a link?
Yeah, in general, the acrylamide levels in a roasted product are depending on how you roast the coffee.
Okay.
Of course, the main or biggest parameter is the green bean you use. So Arabica tends to have higher acrylamide levels in the final product than, no, other way around. Robusta tends to have higher acrylamide levels than Arabica. And also lower qualities of the green beans tend to have higher acrylamide levels. Okay. But with the roasting process, you can influence the acrylamide formation and in the end also the degradation of acrylamide, because coffee is developing a little bit different than starch products like potato chips or something like that, because we pass a certain temperature border. So in coffee we first build up acrylamide up to a certain level until I would say around the first crack, and then we reach this border temperature at which acrylamide is temperature unstable, and we decrease again the levels. So you can say as a rule of thumb, the darker you roast and the longer you roast, the lower will be the acrylamide levels.
Oh, that's very interesting.
Yeah.
So thank you very much for this overview. Yeah, talking about all these important topics like acrylamide, energy levels, I mean, you are here part of our trainer team, so maybe you can just use the opportunity to show our customers which other topics you can handle in your training sessions.
Yeah, so in general, when we talk about, let's say now the acrylamide formation or product optimization, in these cases, we need to go to the customer to work with the customer machines, to work with the customer coffees, because every roaster behaves differently, every coffee develops differently, and there are some fine adjustments you need to consider in this regard. But in general, we are able to deliver all kinds of individual trainings to the product coffee, so from green bean to final preparation, sensory analysis and everything. So these kind of trainings are then really customized to the demands of our clients. But we also offer standardized courses. For example, the SCA courses. So here in Emmerich, we have an SCA certified Premier Training Campus. And also my colleague Marcel and I, we are authorized SCA trainers. And in this case, yeah, we are able to offer SCA courses with a SCA certification, of course. Yeah.
Okay. So you see, if you have any kind of requests or questions regarding training sessions and you want to know more about, for example, green coffee, you can just contact us, our trainer team, and we will find the right training program for all of our customers. So, thank you very much, Ivana. I think that was a very interesting heat session today. I also was looking a little bit to the chats during our session, and I saw that there was a comment from the company Cars Capital, and this company is going to open a new roastery in Germany. And of course, we will get in contact to you. So my colleagues and I, we will get in contact with you, and then we can discuss the details, of course, afterwards. Okay, Ivana.
So in the future, if there are some more questions, of course, please feel free to get back to us.
Sure.
And I think that's it for today.
Yeah. So thank you very much again for your time. It was a pleasure to have you here. And I think we all learned, or at least it was a good knowledge refresher for all of us, but surely we all learned some new aspects of the roasting process. And for you guys, it is important to know that PROBAT is not just a pure machinery supplier here. We are more than that. So we have the knowledge, like over 150 years of experience. So we are the market leader and we want to share our knowledge with you. So don't hesitate to contact us, please. We are looking forward to working with you. Thanks for your time that you joined our heat session today. and we are really looking forward to see you also next time in our next seed session. Thanks and goodbye.
Thank you. Bye-bye.